For number 6, if sine A equals 1 and cosine of B is greater than 0 and sine B equals 1/2, what is the sine of A plus B? So we need to remember about our summation formulas for sine. So the sine of A plus B is the same as the sine of A times the cosine of B plus the sine of B times the cosine of A. Or you might have it in your formula sheet as the cosine of A, sine of B. It doesn't really matter because you'll get the same answer, but we'll keep it consistent. So they tell us that the sine of A equals 1, so we can plug that in. We still don't know the cosine of B, and we don't know the cosine of A, but we know that sine of B is 1/2. So we know that this formula is now the cosine of B plus 1/2 times the cosine of A. Now we need to figure out what these angles are so we can finish the problem. If we are given that the sine of A equals 1, A could only be one possible angle. So we need to remember about our unit circle. For our unit circle, we know that 0 degrees, the coordinate, is 1, 0. For 90 degrees, the coordinate is 0, 1. The coordinate at 180 is -1, 0. And the coordinate at 270 is 0, -1. So if sine of A equals 1, A must be the angle 90 degrees because that is the only place where the sine equals 1. We're also given that the sine of B equals 1/2. So if the sine of B equals 1/2, it could possibly be in one of two quadrants. It could be in quadrant 1 or quadrant 2 because that is where sine is positive. And we know the opposite side of 1 and the hypotenuse is 2. However, it also tells us that the cosine of B must be greater than 0. So that eliminates the triangle in the second quadrant because the cosine would be negative. Therefore, angle B must be 30 degrees because 30 degrees is across from 1. So B is 30 degrees. Now we can finish this problem. So now I need to find the cosine of 30 degrees plus 1/2 of the cosine of 90 degrees. Well, if I finish drawing my triangle, we know that the second side is √3. So the cosine of 30 degrees is √3 over 2. And if I look at the cosine of 90 degrees, the cosine is 0 because the cosine is the x value. So now we just have 1/2 times 0. So our final answer would be √3 over 2. In number 7, we want to find the interior angle measure of the two lines that both contain the point 0, 0 and have slopes of -1 and 1/2. So let's go ahead and draw a picture of what this would look like. So if I had a slope of -1, I would have a line that starts at 0, 0, and we go down 1 and over 1. Or we could go up 1 and over 1. So we have the following line. All right, and then if we have a line that contains the point 0, 0 and a slope of 1/2. I know that will be up 1 and over 2 from 0, 0. So if I draw that line, be right here. So we want to find the interior angle measure of those two angles. So I believe the interior angle measure would be the angles that attach to the x-axis, both of those measures added together. So what we can do is draw a triangle for each line and find their angles. So if we look at the first line with the slope of -1, we know that we had to go over 1 and down 1. So hopefully you remember a triangle where you go over 1 and down 1, or a triangle whose both sides are 1, and that would be a 45-degree angle. So we know that this part of our measure must be 45 degrees. For our second triangle, the one with a slope of 1/2, we know that this side must be 1 and this must be 2. And there is no special triangle with this side, with these sides, so we must take an inverse tangent. So we know that the tangent of theta, the angle we're looking for, equals opposite 1 over adjacent 2. So if we do the inverse tangent of that in our calculators, theta equals 26.565. So make sure you are in degree mode when you figure that out. So now we just need to add 45 to that angle to find our interior angle. So our final answer will be 71.565 degrees. For number 8, we need to do some factoring that we might not necessarily be used to doing. So you're used to factoring something simple like this, x squared plus x. And usually what you would do is you would say, well, x is the smallest, so I can factor that out. And then everything goes down 1 degree. So x squared is just going to become a regular x, and the x is going to become a 1. What we're about to do is very similar to that. So if I see that I have 2x plus 1 repeated, I know that I can factor that out. And I want to factor it out with the smallest exponent. The smallest exponent is -1/2. I also see that there is a 4 in both terms. So I'm also going to factor out that 4. So I'm going to factor out a 4 and a 2x plus 1/2, or plus 1, to the -1/2. So now the challenge is to see what's left over. So for the first term, we still have the x left over. And we are going to, since we factored out the -1/2, that is no longer left there. So let me erase that. Okay, with the next term, that 4 is gone, and since I factored out the -1/2, that 2x plus 1, we want to subtract a -1/2 from it. So 1/2 minus a -1/2 becomes a 1. So we're just left with 2x to the first power. So now the problem says express the answer as a fraction without negative exponents. So this -1/2 is going to send just this part of the expression to the denominator. So in the numerator, we have 4 and then times x plus 2x plus 1. We can actually combine some like terms there. So that'll become 3x plus 1. And then the 2x plus 1 will go to the bottom, and that will have a positive 1/2 exponent. If you would rather express it as a square root, then that's also fine. All right, for number 9, we need to find the smallest value of x that satisfies the equation. So it's basically asking you to solve, but just take the smallest value. So if we factor it, we are going to get an x, that doesn't work, x minus 3x minus 2, because that would give us a positive 6. So it looks like what we need to do is use the quadratic formula in order to solve this equation. So the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So we have a positive 5 plus or minus the square root of 25 minus 4 times 1 times a negative 6, so plus 24, all over 2, which gives us 5 plus or minus the square root of 49, all over 2. Oops, it looks like this one is factorable. I forgot to try this combination. X minus 6 and x plus 1. That way works. But the quadratic formula would have given us the same answer. So our two x values would be 6 and negative 1. And negative 1 would be the smaller of the two that we are looking for. For the last problem, we want to rewrite some stuff to make it a little bit easier to solve. So if you ever see something raised to the negative 1, you can always put it in the denominator. So this is 3 over x plus 2. And I'm going to take that 4 over x and just move him to the other side. Now, this is a pretty easy problem to solve. We just need to solve by cross multiplying. So we get 3x equals 4x plus 8. Let's subtract the 4x over. So we have negative x equals 8. So our final answer is x equals negative 8.